Hello, this is Norm, the amateur machinist, and I want to do another short video for you to explain a term that is used sometimes in machining nomenclature, and oftentimes it's used, but it isn't explained. And some people, probably most machinists, know what they're talking about, but someone that's new to machining may not. And it's the word tangent. Oftentimes you'll hear a machinist say something, well, I'm going to put something in a vise and put a ball in there where it'll make tangent contact with the movable jaw, or maybe even the fixed jaw, so that it can hold an odd-shaped object in the vise. Well, what do they mean by tangent contact? Okay, well, in the dictionary, it defines tangent as a line that touches a curved surface, but it doesn't intersect it. It touches it in one and only one point. And I want to further illustrate that with a little diagram I have here. And hopefully that'll clear up the term tangent for you when you hear it, when you watch videos of machinists making things and using that term. Okay, so here's where it would be used in a machining environment. I've drawn a picture here of a vise. This object here, this rectangle and this screw is a vise. And this is the movable jaw of the vise, and this is the fixed jaw. And suppose you want to hold in the vise an object that looks like this hashed area, kind of an odd-shaped area. And it would be awkward to try to squeeze that in the vise because the distance from here to here is greater than the distance from here to here. So if you try to tighten the jaw, the movable jaw, it'll make contact here, but then it'll want to cant to try to make contact with this area here, which is not good for the vise. It may not even make contact with that area, and you'll have a real lousy fit. So oftentimes machinists, what they'll do is they'll put a ball or a cylinder in here that will make tangent contact with the movable jaw. They'll use that term, tangent, and I'll draw it in here. Now, if you draw in a circle, I got to do this, like this. Now, that circle could be either a steel ball or a cylinder that you've machined so that it will make the proper contact where this movable jaw surface here will be perpendicular to the side of the vise, and you'll get a good tight fit. You'll have pressure put on the object here, and you'll have pressure put on the object here. Well, the machinist will refer to that as tangent contact with the movable jaw, meaning that this curved area here, this curved area, makes one and only one contact point with the movable jaw. And so it's a tangent contact with the movable jaw. Now, some of you have studied calculus before. You may look at this and say, this is familiar. In calculus, the differential calculus anyway, the idea is to find the slope of a line that is tangent to a function. Let's say this is a function at x. I'm trying to draw this here through the phone. Function at x equals x squared. Now, I'm not going to get into calculus. I just want to get into the term tangent here. Anyway, the idea is to find the slope of that line which is tangent to the function. Again, we have a curved line, and it's not really proper to call it a line because the line is straight. But anyway, we have a curved line, and we have a straight line that makes tangent contact with the curved line. Okay, the slope of that at that point is the rate of change at this point right here on the x-axis. Okay, enough for calculus. That'll be another whole video when I cover the central idea of differential calculus. That's beyond the scope of this video. So anyway, the main central theme of this video is to cover tangent. Tangent meaning it makes contact in one and only one point of a line. So now hopefully that will help you understand more when machinists talk about making tangent content. And so again, this is Norm, the amateur machinist. I'm going to sign off, upload this video, and I think this is my 5th video now. So we will see you on the next video.